looks like. If you had a box, I'm looking on the margin here, figure 1-4. If you had a box, a little matchbox, and you put 6.25 times 10 to the 18th power electrons in that matchbox, that would be 1 coulomb of electric charge, okay? 6.25 times 10 to the 18th power is 625 with 16 zeros behind it, okay? I think that's 625 quadrillion, okay? Now, if this little box, like a race car, crosses the finish line, once one of those every second, assembly line shooting out one of these boxes every second, that is 1 amp. So 1 amp past a given point every second, 6.25 times 10 to the 18th power electrons past a given point every second is an amp. Okay? What did we say the I stood for yesterday? V is equal to I times R. What did I stand for?
Amps.
Yeah, but what did the I stand for? It does stand for amps, but the I stands for intensity. Intensity of the water flow. Okay? You can have water flow, and then you can have, flash flood, you're going to drown water flow. All right? Whitewater rafting or just kind of chilling, tubing down the river. All right, now figure 1-4 also, if it shows in figure number B there, 1 coulomb of protons. Now above that it shows 1 coulomb of electrons. What's wrong with that picture? Is that picture aesthetically correct? Is it physically correct? No. Because the proton is 1,840 times larger, the boxes couldn't be the same size. Okay, so that box would be about as big as this room. All right? Okay. Important information. 1-5, page 33 on your book. In your book, the volt unit of potential difference. Okay? That's something you're going to see quite a bit. Potential refers to the possibility of doing work. And the volt is the unit of potential difference. Okay? It is the push. All right? So, if I got 10 volts here on my wire, and I have 0 volts on this side, and I come along with my meter, and I touch one lead here, and I touch one lead there, I'm going to measure 10 volts because there's 10 volts of difference. Now, if I've got 10 volts here and 10 volts here, I'm going to measure 0 because there's no potential difference. Okay? Troubleshooting tip. You cannot measure voltage across a closed switch. If you close a switch, it's going to measure 0 voltage. If you open a switch, it's going to measure the amount of voltage across that switch because it's open. Okay? So the volt unit of potential difference. Right? When the potential difference between two charges causes a third charge to move, the charge in motion is electric current. Okay, so charge in motion is current. Charge in motion is current. Okay? All right, now we looked on page 34 with the volt yesterday. We looked about